Hello and welcome to another one of D's ADD videos. Today we're going to be looking at a couple advanced domain problems and trying to go through the steps necessary to solve them. Hopefully by the end of this you'll be really comfortable with domain, comfortable enough to try any problem. All right, so in this problem you should notice that we have two of the three rules present. We have the square root and the denominator. So with the two restrictions present, first, the term inside the square root must be positive. You should be well familiar with these basic concepts by now. And the term in the denominator can never equal 0. So what we're going to do is we're going to apply both rules and combine them on a number line. So let's see it in action. Let's look at that first one. Terms inside the square root must be positive. The way we deal with terms inside the square root needing to be positive is setting them greater than or equal to 0. So if we set it greater than or equal to 0, we just subtract the 1 over, and there's the first part of our answer. Now what we're going to do is we're going to look at the denominator. The denominator cannot equal 0, because if we get a number over 0, then it's undefined. So whenever we're factoring the denominator, in this case it's not too complex, and you get x cannot equal 6 and x cannot equal negative 3. So what do? Well, we now have to combine both answers and plot them on a number line. So let's plot away, and when we plot, we're going to get this following number line. We have open dots for the two terms from the denominator. Denominator cannot have it equal to 0, and both of these make the denominator equal to 0. And then here, greater than or equal to negative 1 would be starting at negative 1 and pointing to the right direction. We can't include the 6 because that's restricted from the denominator. So when we look at this, we don't even consider the negative 3 because it doesn't satisfy the greater than or equal to negative 1 part. We just look at everything to the right of negative 1. As a result, your final answer would be from negative 1 to 6, union from 6 to infinity. All right? Hope that's clear. We just use both rules on the same number line, combine the answers. All right, let's check out this next problem. So if you remember, you cannot take the square root of a negative number, so whatever's under the radical, you're going to have to set greater than or equal to 0. Okay? So whenever you do that, you get this. Now this is a whole new problem. This is an inequality problem. This is an inequality greater than or equal to. So what we have to do is we have to say, can I just solve it outright, or do I need sign analysis? And if you have a fraction and an inequality, you have to do sign analysis. Also, there's a power of x greater than 1. That's the other scenario whenever you have to do sign analysis. So anytime that you have an inequality, one of these guys, greater than or equal to, and the power of x is greater than 1, or if we have a fraction, we have to do sign analysis. Sign analysis. Go back and review the videos if you need to on sign analysis. They're under the advanced inequality videos. So what we're going to do is we're going to set the top and the bottom equal to 0, and we're going to solve them independently to get our cut points. Okay. So when you do that, the first one's easy. The top is just 0, but the bottom you do a little difference of two squares factoring, and you get your x plus 3, x minus 3. Set them individually equal to 0, you get plus or minus 3. So these are your cut points. The next step is to draw a number line and plot your cut points. And here I want you to take note that some of them have open dots and some of them have closed dots. Why is that? The reason behind that is because 0 came from the numerator. And it's okay if we equal 0 in the numerator. But the 3 and the negative 3 came from the denominator. And we can never equal 0 in the denominator. So therefore they get open dots. Now what you got to do is you got to pick some test points on either side of your open dots, and you're going to plug them into your fraction and determine whether they're positive or negative. So here I picked negative 5, negative 1, 1, and 5. You could have picked any point to the left and right of each of these cut points. And when you plug them into your fraction, you don't care about the actual specific value. All you care about is whether it's positive or negative, okay? And here for domain, we care about the positive numbers for domain. So if I plug in a negative 5, the top is going to be negative, the bottom is going to be 25 minus sign, which is positive. So negative over positive is negative. If you follow that pattern all the way down, you get that the two positive regions occur between negative 3 and 0 and from 3 to infinity. So those would be your domain answers. And when you use your open circles, we have a parentheses. Closed dot or circle is going to be a bracket. That's a bracket. And then for infinity, we always have parentheses, whether it's positive or negative infinity. Again, review your sign analysis if you need to. More importantly, practice, practice, practice. That's the way you're going to become good at this stuff and make it second nature and not be surprised on a quiz or exam. As always, thanks for watching. Have a great day.